Welcome to myprojectbazaar.com. Our project title is R3E Reliable Reactive Routing Enhancement for Wireless Sensor Networks. Abstract: providing reliable and energy efficient communication under fading channels is one of the major technical challenges in wireless sensor networks, especially in industrial wireless sensor networks with dynamic and harsh environments. In this work, we present the reliable reactive routing enhancement to increase the resilience to link dynamics for WSN and IWSN. R3E is designed to enhance existing reactive routing protocols to provide reliable and energy efficient packet delivery against the unreliable wireless links by utilizing the local path diversity. Especially, we introduce a biased backup scheme during the route discovery phase to find a robust guide path which can provide more cooperative forwarding opportunities. Along this guide path, data packets are greedily progressed towards the destination through nodes cooperation without utilizing the local information. Through extensive simulation, we demonstrate that compared to other protocols, R3E remarkably improves the packet delivery ratio while maintaining high energy efficiency and low delivery latency. Let us see the flow of our project. First, in our project, we have to create the nodes in our wireless sensor network. Then the nodes are sensing the range between the neighbor nodes. Then we have to implement our AODV R3E protocol for high throughput and packet delivery ratio. Meanwhile, we have to identify the route selection based upon the residual energy. So residual energy is nothing but the node which have the highest energy is taken as the routing path, and the data transfer between that node. So first we have to route selection based upon the RREQ. RREQ means route request. Meanwhile, we have to identify the attacker. If the attacker is identified, we have to verify the routing table according to the sequence number, ID, hop count, destination and source. And also we identified the shortest path to the destination. Then data transmission is done. Performance analysis is done by using throughput calculation, packet delivery ratio, delay and energy. Let us see the output of our project. First open the Red Hat VMware, then open this terminal window and go to our directory folder, project folder directory. So type cd space code, and this is for running our ns main.tcl file. So type ns space main.tcl .tcl. So now the highest antenna size is defined here. This is our output window, which is called a network animation window. So this is our play forward button. So this is for speed upping the time. So we put the speed as 20 milliseconds. So first we have to form the network, and source and the sync node is formation. So source node is 8 and a destination node is 13. So first we have to construct the node. Next, route selection is based upon the RREQ is done. So now the node 8 sent the information to the node 18, but the node 18 is act as a malicious node. So we have to identify that node, and so now this 18 node which drop all the packets. So now the packet dropping ratio is defined here. So we have to identify the malicious. So this also annotated here. The node of 18 drop the packets. Now the data transmission done via the another node. So this node has also act as a neighboring node. Now the node transmission is done via 6, and the 6th node sends the information to 2. but do also act as a malicious, and then so the source now take the bypassing the packets and sends information to the trustworthy nodes. So now the data transmission is done without any malicious nodes. So now the data transmission is done via the 4 and the third node. So via the 0th node, the data packet will be sent to the destination. So for running our graph file, we have to type GNU space that graph dot plot. For that, open our code folder. So this is our code folder which contains our code, and this delay.awk, throughput.awk, and network overload AWKs are all generating our graph. So go to that coding folder and type awk space hyphen f space delay.awk space out.tr. So this will generate one file. So next we have to, this graph will be plotted using xgraph. So type xgraph space delay.xg. So this is our delay graph depending upon our output simulation. Thank you for watching.